let capital A represents a 3 cross 3 matrix such that it satisfies these three equations. A into this column vector 0, 1, 0. This is 0, 0, 1. Similarly, A into another column vector. This is 0, 1, 0. And finally, A into this column matrix 2, 1, 2. This is 1, 0, 0. Then we have to find the element of second row, third column for this matrix A. Now, the general method of solving this problem is to start with a general 3 cross 3 matrix, and then using these equations we have to find the elements of matrix A. But there is another much easier method of solving such problem, and these type of problems, they are very common in JEE Main, where you have one unknown 3 cross 3 matrix A, and then there are three matrix equation and something related with matrix A. This is asked in the problem. So here what we can do is that we can combine these three matrix equation and we can create a single matrix equation. Also here, if you notice, these right hand side, they are nothing but columns of identity matrix. So here in fact you can create a matrix equation of the form A into some other matrix B equals to identity matrix. And if we have that equation, that A into B, this is I, then clearly matrix A, this is nothing but inverse of matrix B, right? Matrix A will be B inverse and matrix B, this will be A inverse. So, but for that we have to know how we can combine these three equations and we can write a single matrix equation. So see, in case of identity matrix, the first column is 1, 0, 0. Now here 1, 0, 0, this is given in the third equation, right? 1, 0, 0, that is third equation. So we are going to write this equation first. That means right hand side 1, 0, 0, and on left hand side we have A into 2, 1, 2. So for this matrix B, the first column will be 2, 1, 2. And matrix A multiplied by this column matrix 2, 1, 2, that will give us 1, 0, 0. Similarly, for identity matrix, the second column is 0, 1, 0. This column is given here, right? So therefore, the left hand side for this matrix B, the second column, that should be 4, 1, 3. And matrix A multiplied by this column matrix 4, 1, 3, that will give us this column 0, 1, 0. And finally, for identity matrix, the last row, last column, this is 0, 0, 1, the third column. So, and for matrix A into this column 0, 1, 0, that is 0, 0, 1. So matrix A multiplied by this third column, that will give us 0, 0, 1. So now we have this equation that A, and if I call this second matrix as matrix B, so then we have this equation of the form A into matrix B equals to identity matrix. And if A into B is identity matrix, then matrix B, this is nothing but A inverse. And now we can calculate anything related with matrix A, because matrix, in fact, matrix B is A inverse, and you can also show that you can also write the same thing as matrix A is inverse of matrix B, because here matrix B is known and it is matrix A that we have to find, right? In fact, we have to find the element in second row, third column, right? We have to find A, 2, 3 for this matrix A. So now let us try finding B inverse, right? Now we are going to find inverse of matrix B, and then we'll see what should be the element in second row, third column for this matrix B. Now remember, for finding inverse of any matrix, we need two things. One is the adjoint of matrix, other one is determinant of the matrix. So first let us calculate determinant of matrix B. Right, determinant of matrix B, we can expand along the third column because we have two zeros there. So we can write minus 1 into, and then we have 2 into 3, 6, minus 4 into 2, that will be 8. So determinant of matrix B, this is 2, right? So that means B inverse, this will be nothing but determinant of matrix B, and that multiplied by adjoint of matrix B. Now remember, adjoint is nothing but transpose of cofactor matrix. Here we are not going to calculate all the elements because we are interested only in the element of second or third column. So for B inverse will be adjoint of B, and that divided by determinant of B, and adjoint is transpose of cofactor matrix. And for matrix A, we need the element of second row, third column, right? So that you will get from the element of third row, second column after taking transpose of the matrix. So here we'll not write the element of first row, will not write the element of second row also. And in third row, only will find this element, right? Element of third row, second column. Because once we take transpose, then we are going to get the element of second row, third column. So now this element, this will be cofactor of element in third row, second column. That means cofactor of this element 3, right? So that will be 2 into 1 minus 1 into 0, that is 2. Minor will be 2. And for this particular element, I plus j will be odd number. So if minor is 2, cofactor will be minus 2. That means for B inverse, the element of third row, second column, this is minus 2. And after taking transpose, this element will come to second row, third column, right? So therefore, from here directly you can write A2, 3. Once we take transpose of this cofactor matrix, then this minus 2, this will come to second row, third column, and that divided by determinant of matrix B. So that will be minus 2 divided by 2, which is minus 1. So this should be the element of second row, third column, and hence the correct answer for this problem, this will be option B, right? So this is very interesting concept, and there are number of PYQs from this concept where you have one matrix A, a known matrix, and three matrix equation, and then you have to find something related with this matrix A, right? So in that case, you can always combine all of those three equations and you can write matrix equation on this form. Here we got identity matrix, but in some other problem you might get some matrix C. But in that case also, I mean, if I can write this equation that matrix A into B, this is some matrix C, and B and C, these two are known matrix, we have to find matrix A. So then multiply both sides by inverse of matrix B. So matrix A, this will be nothing but C into B inverse, right? And sometimes there are determinant related problem that find determinant of matrix A. So then you can take determinant on both sides and from there you can calculate these things. So it is an important concept and you should know how to combine these matrices, matrix equation. Here after combining, we got matrix A as B inverse. Then we calculated B inverse, and because we were interested only in the element of second row, third column, so we calculated only this particular element, right? And finally, A to 3, this was minus 2 by 2, which is minus 1. And hence the correct answer for this problem is option B.